Okay, class, welcome back. This is lecture 9. Today we're going to talk about multiplying and dividing polynomials, the things that we learned about last time. But last time we only saw how to add and subtract them. Today we're moving on. Okay, so first is multiplication. So we can multiply polynomials the same way we multiply numbers. We use something called the distributive property. So for numbers, it's a little bit easier to see. So if I do like 3 times 2 plus 10, I can distribute this 3 to get 3 times 2 plus 3 times 10. And that gets me 6 plus 30, gets me 36. Whereas if I want, I could have just added the 3 and the 2 in the first place to get 12, or sorry, the 2 and the 10 to get 12, and 3 times 12 just happens to be 36. So works either way. And so for polynomials, it's the same idea, just looks a bit fancier. And then it gets a little bit weirder when you have the addition of two things. Let me pick two different numbers. Something like this being multiplied together. So then when you distribute, each number gets multiplied to each number. So this 2 gets multiplied into that 1 and that 6. And then the 4 also gets multiplied into the 1 and the 6. And there's many ways to think about it, but that's the idea. So we're just going to jump into some examples with polynomials instead of just numbers. So let's multiply, aka simplify, something like this. So 2x plus 1, that's one polynomial of degree 1. 3x minus 2 is another polynomial of degree 1. So how do we multiply this out? We do 2x multiplied to each of these guys. So 2x times 3x plus 2x times negative 2. So the 2x gets multiplied to each one, and then you add. And then similarly, the 1 gets multiplied to each one as well. So plus 1 times 3x plus 1 times negative 2. And now we simplify. So the first thing to recognize is, what do we do here? So what's 2x times 3x? Well, there's many ways to think about this. 2x really just means 2 times x. So this is really just 2 times x times 3 times x. If you want to think about it like that, all multiplied together. And when you have just pure multiplication, you can switch the order of things around. So this is really 2 times 3 times x times x. So then I can multiply the numbers together, and I can multiply the x's together. So what's x times x? Well, we have another way of writing that as, and that's x squared, right? Something squared means times itself. So we would just write this as 6x squared. Now you don't have to do that work every time. You just have to notice that I'm just multiplying the numbers together, and I'm just multiplying the x's together to get x squared. Okay, so here, same idea. I'm just going to multiply the numbers together. So 2 times negative 2 is negative 4. And there's no other x's, so it's just negative 4x. And then over here, it's just 1 times 3x. 1 times anything is the same. And 1 times negative 2 is negative 2. So this is the first step. And then we could do what we did last time, which is combine like terms. So this is a single power of x, and so is this. So I have negative 4x's and 3x's. That will add up to negative x. And the 6x squared and the 2, negative 2, have nothing else to do. So that's all there is to that one. Okay, so distribute, then simplify. That's the key. It can get a little bit more complicated because you can have more terms more powers of x if you want. You can have as many as you like. It just takes longer and is more annoying to do. But let's do it just for practice. Okay, so let's simplify, aka multiply out this thing. X minus 4 is the first polynomial, 2x squared minus 5x plus 3 is the second polynomial. So the second polynomial this time is a higher power one. It's degree 2. And so how does this work? Well, now it works very much the same. This x is going to get distributed to each term. So now it has to go to 3 terms instead of just 2 like last time. So I'm going to get x times each one, 2x squared plus x times negative 5x plus x times 3. Now, I should mention that when you get really good at this, you can sort of skip the step I just did, and you can sort of immediately realize some things. But that's once you've had more practice. So don't worry about it yet. You can just do it this way. Okay, so now the negative 4 has to also distribute to each term. So negative 4 times 2x squared plus negative 4 times negative 5x plus the last one is negative 4 times 3. So I've distributed it to everything. And now I'll simplify. So x times 2x squared, what happens there? Well, again, let's think about it outside the box first. So x times 2x squared means x times 2 times x times x. Well, what we do is we put the number in the front when we multiply number times x, and then we have 3 x's. So what do you do when you have 3 of the same term multiplied together? You write it as that thing to the power of 3, right? So because x cubed is x times x times x. So in general, x to whatever number you want is just that many x's multiplied together. So we're going to keep that in mind so that we can skip steps. X squared is just x times x and so on like that. Okay, so what we get here is 2x cubed. But again, the shortcut is multiply the numbers together. There's no other number, so it's just 2. Multiply x and x squared, and that becomes x cubed because you have 3 x's total is the idea. You can really just add how many x's you have. Okay, so then let's do the next one. So x times negative 5, x is going to be negative 5 because there's no other numbers to multiply it to. And how many x's do we have total? X times x is x squared. And then 3 times x is 3x. Now over here, negative 4 times 2 is negative 8, and we only have x squared, so no other x's to multiply. And then negative 4 times negative 5 is 20, and there's no other x's to multiply. And then negative 4 times 3 is negative 12. And now we just have to identify those things that have the same powers and stick them together. So there's only 2x cubed, but there's negative 13x squared. So if I put the negative 5 and negative 8 together, there's 23 x's, and then there's only negative 12, another number. So that's it. Okay. So then what we could do is we could do something with functions again, like we did last time. So then let's do that. So if we have 2 functions, then we can write them as f times g. So last time we added and try to create a new function. So f times g of x is going to be multiplying them instead. So creates a new function. Instead of adding, we multiply. So it's f times g, and it's going to just be f of x times g of x. So if we have f of x and g of x as 2 polynomials, we can just multiply the way we have been. So let's do that real quick. So f of x will be x squared minus 9 g of x will be x squared minus x minus 3. So then if I want to figure out this new function created by multiplying my two functions that I have, all I got to do is multiply the two polynomials. So now we have lots of practice doing that. So let's do it. Okay. So we're going to multiply these out again, and we're going to keep seeing this pattern. So x squared is going to go into each one of these. And now I'm going to be a little bit quicker. X squared times x squared, I'm just going to do it instead of writing x squared times x squared, because what I can do is I can do that in my head. I can say x squared times x squared. That's just 4 x's multiplied together. So that's just x to the fourth. And it's done by actually adding. So I'm just using a quicker method, which is that if you multiply 2 powers of x, then the total number of x's is just however many there were added together. So like this would be x to the 11th. So x squared plus x squared would be x to the 2 plus 2, which would be x plus x to the fourth. Okay, so then x squared times negative x is 3 x's. So it's x cubed. And then x squared times negative 3, well, there's no number besides negative 3. And there's no other x's to multiply to, so it just stays as x squared. So that's distributing that way. And now I distribute the negative 9 through. So the negative 9 times x squared becomes negative 9x squared because there's no other number multiplying to the negative 9, and there's no x's multiplying to the x squared. And then negative 9 times negative x, now the negatives will cancel, but the 9 and the x have nothing to multiply to. And then the 9 times the 3 will now give me 27, but the negatives will cancel, so it'll be positive 27. Okay, so then I am simplifying. There's only 1x to the fourth. There's only 1x cubed. But I can combine these two guys together to get negative 12x squared. And there's no other x's, and there's no other just numbers. So that's it. So that's my multiplied function. Okay, so this is multiplying polynomials. You just got to keep practicing. And if you are uncomfortable with how I skipped the steps I did before to get from there to there, I would recommend writing out the steps I did before and seeing that you'll get this as your answer. Okay, so that is multiplying polynomials. Next, after you learn to multiply, you learn to divide. Dividing polynomials is a little bit trickier, but we have previous knowledge to go off of. It actually looks very similar to dividing numbers. With long division. So that process is kind of annoying to do, but we can do it. We can remember how it goes. So let's remind ourselves about that. So you can do something like 70 divided by 6, which also means 70 over 6. And how do you do this with long division? Well, you take the 6 and you stick it here, and then you put a little box and you put the 70 in there. And then how do you actually calculate the answer? You pick numbers, right? So you say, how many times does 6 go into 7 first? And you say, oh, it just goes in once. And then you multiply that 6 times that 1, and then you subtract, and then you bring down the next digit, and then you do the same thing. So you say, how many times does 6 go into 10 now? It also goes in once. Then you multiply the 6 and the 1 to get 6. You subtract and you get 4. And then there's nothing left to bring down, so you call this thing your remainder. And so then you can say 70 divided by 6, or 70 over 6, equals 11. And then 4 6's left. That's the idea. And now for polynomials, it'll work very much the same. So let's compare it. Okay. So what we do is we calculate, or say it different ways, divide. You divide a bigger degree polynomial. So x squared, whoops, x squared minus 3x plus 2 divided by a smaller degree polynomial, x minus 3. So just like we did a bigger number divided by a smaller number, that's what we're doing here, bigger polynomial divided by a smaller polynomial in terms of degree. And this is the same as saying the bigger polynomial on top of the other as a fraction. And to get it, we do long division. But the long division looks a little bit different. It's very similar. So you put the smaller polynomial on the outside still, just like you put the smaller number there, and you put the bigger one in the box. And now we ask ourselves, how many times does x go into x squared? So we're looking at this x, and this x squared is the idea. And I want to stick something here that answers this question. So the idea is this x times what goes into x squared. That's what, when you ask the question, how many times does something go into something, you're asking what do you have to multiply it by to make the other thing? So what do I have to multiply by to get x squared? Well, just another x, because then I get x times x, and that it gives me x squared. So x is what I'm going to put here, because that's how many times x goes into x squared. And then I'm going to multiply just like before. So I'm going to multiply. So then multiply. So just how I multiplied my 6 times the number, I'm going to multiply this times the number, except it's not a number now, it's an x. So I'm going to multiply that times that. And that's going to go down here. Okay, so I have to do x times x is x squared, and x times -3 is -3x. So I'm distributing by doing x times x minus 3, and that's going there. And then in the number example we subtracted, we're still going to do that here. We're going to subtract the whole thing, so you got to have parentheses around the whole thing. And what do we get? Well, x squared minus x squared is 0. It's like saying 5 minus 5 is 0. You're subtracting the same thing from itself. And actually, so is -3x minus -3x. So those are actually both just 0. And then I'm going to bring down the 2. And this is going to be the remainder is just 2. That's because x does not go into 2. So you're done. So there's no more things to put. So then what does this mean? How do we interpret this work that we just did? Like how we interpreted 70/6 as being 11 and the leftover remainder. We interpret this as, this is x, and a little bit more plus the remainder over this much, what we were dividing by. So this is what we are looking for. So the x is coming from here, and the remainder 2 is there, and then it's the same thing you're dividing by. It's coming from there. Okay, so we'll do a couple more examples. So let's do a bigger example to sort of see this process in all its glory. Okay, so the next one I want to do is this one. Find and interpret this. So like, what does this mean we're doing? And also, let's calculate it. x cubed plus 4x squared minus 5x plus 3. So this means I'm dividing this big old x cubed thing by x squared plus 1, right? That's what this means. I'll write that at the end as well. But now let's practice this process because it does take a lot of practice to get it down. So the first question is, how many times does x squared go into x cubed? That's the first question, and that's what we're going to stick here. So x squared times what gives me x cubed? Well, I just need one more x. I need one more power of x to get that. So x squared times x is what's x cubed. So this needs to be an x here. And then I'm going to multiply x squared plus 1 times that x. And what are we going to get? So you could do it on the side if you want. X times x squared plus 1 is going to be x cubed plus x once you distribute that in. So that's what I put underneath, x squared plus, x cubed plus x. And then I'm going to subtract. But I need to align things properly so that when I subtract, it makes sense. So this power of x here, I should actually put over here. And then, since I have this blank space where I should have an x squared, I'll just write it as not having any x squareds, meaning I have 0 of them. And this will make the alignment look a little bit nicer. And now is when I will subtract. Okay, so subtracting x cubed minus x cubed gives me 0. 4x squared minus 0x squared gets me 4x squared because I'm taking away nothing. And negative 5x minus x is going to get me negative 6x. Another way you can do this is you can think about it as, I'll just distribute this negative through first and then add, if you like. Very similar. So once you've subtracted, the next step is bring down the next term and then repeat the process. So last time we didn't have to repeat the process, we were done. But this time, x squared still goes into this next thing, so we have to repeat the process. So the next question is, how many times does x squared, so x squared times what, go into 4x squared? So what do I need to multiply x squared by to get 4x squared? Well, I just need a 4 here, and that will get me 4x squared. So it goes into it 4 times, and so that's what we are going to put there. And then again, I'm going to multiply out this thing times what I just put there. So now I need to figure out, maybe on the side somewhere, what is x squared plus 1 times 4. It's just 4x squared plus 4. So if I multiply that 4 into this x squared plus 1, I get 4x squared. And then plus 1 times 4 gives me 4, but I'm going to align the two numbers there. And then I'm going to subtract, and I'm going to put in this filler 0x just to make the alignment nice. And now we're going to subtract. So you should notice the first terms always cancel. 4x squared minus 4x squared is 0. And that's how we set it up. That's why we picked that 4. And we asked how many times does it go into that thing for that reason. Okay, so then negative 6 minus 0 just stays negative 6. 3 minus 4 is negative 1. So this time, now we're done here, and this is our remainder. So our remainder can have x's in it. It doesn't just have to be a number. And this is the remainder because x squared has a higher power than x. So x squared does not go into it. Does not go into this thing. So there's nothing else we could put there. And instead, this is the end. This is the remainder. Okay, so now how do I interpret this thing? What does this mean? Interpret. It means that when I divide this polynomial that's on the inside divided by this one that's on the outside, that the result is the thing on the top, x plus 4, but there's this remainder, negative 6x minus 1, out of this many things. This is what we divided by, so that's still on the denominator. So that's the interpretation. How many times does x squared plus 1 go into this other guy? It goes into it x plus 4 times, but then there's this remainder. So it's a bit different than numbers, but very similar. In any case, that's the end of that one. All right, so let's do another one. So let's do x minus 8 into x squared. Well, actually, first let me write it like this because I want to show you something. So let's divide x squared minus 64 by x minus 8. So this means, of course, figure out this guy again, i.e. get this thing. And so what we're supposed to do is we're supposed to put our x minus 8 out here and our x squared minus 64 here. But hold on, don't write it yet, because what we have to do is we need to fill in the blank for alignment purposes. So we have to notice that there's no power of x. And so what we're going to do is we're going to write that power of x as 0 x's, just so that things align nicer. Okay, and now we're ready to continue. So first things first, how many times does x go into x squared? It just goes into it x times, because x times x will give you x squared once you multiply it out. So now we're going to multiply it out. X times x is in fact x squared as we planned. And then x times negative 8 is negative 8x. And now we are going to subtract. And so x squared minus x squared is 0 as always. That's how we planned it. 0 minus negative 8x is 0 plus 8x. So this is an 8x. And now I'm going to bring down this extra number here. And now I have to figure out how many times does x, again, just always looking at this, go into 8x. Well, it goes into it 8 times because x times 8 is 8x. So that's my next thing. And then I distribute the 8 into the x minus 8, and I get 8x minus 64 because 8 times negative 8 is negative 64. And then I subtract, and we're going to get something sort of different this time, more interesting. So 8x minus 8x is 0. Negative 64 minus 64 becomes negative 64 plus 64, so they cancel and get 0. So what is this? This is a remainder of 0. Remainders of 0 are great. That means it divides into it perfectly, which is something we haven't thought about yet, but it'll come in handy a lot. So what this is saying is if I divide x squared minus 64 by x minus 8, I end up with this thing on the top, x plus 8, but there's no remainder, so I don't have to add any weird fraction. So that's just it. So this is sort of more interesting because there's no weird fraction at the end like the other ones. So this means there's going to be no fraction at the end if you get a remainder of 0. It's very similar to if you divide by something that actually goes into it, like 30 divided by 6 goes into it perfectly 5 times, there's not going to be a remainder if you do this long division process. So this is something that can happen, and we'll come back to this kind of stuff a lot eventually. But in any case, that's going to be it for this video. We're just going to be practicing this process a lot. Okay, see you next time.